optimising her significancy. So over to Helen.
Thank you, Sunil, and to Explain for this invite. I'm delighted to be here and actually present to you. So I'm CEO of ClotProtect Therapeutics, and what we're trying to do is develop a first-in-class therapeutic to address the unmet needs of the standard of care to treat acute bleeding. So I'm also the chair of the International Society of Fibrinolysis and Proteolysis, which is the international society that deals with clot breakdown. I'm also a professor of translational medicine at the University of Leeds.
Can you just put the hand out?
Next slide. To the next slide, that'd be great. Okay. So,
Don't worry.
So what we're doing is developing the first-in-class direct selective plasmin inhibitor to address the unmet needs of tranexamic acid, which is the standard of care treatment. And essentially what we're looking to do is raise 10 million for our seed round that it takes to being ready for first-in-man studies. And what we believe we will achieve is greater efficacy than standard of care, tranexamic acid, which will result in less bleeding, less deaths. But in addition, plasmin is responsible for initiating inflammatory responses. So often what happens is patients have pro-inflammatory effects. Actually, even if the bleeding's been stemmed, they go on to develop multi-organ failure and die in intensive care. So next slide, please. So this is our team. I previously co-founded Lunac Therapeutics with my co-founder, Richard Foster. We raised in excess of 18 million by way of granting Pharma and Life Science venture funds. And then we've got our Chief Business Officer, Ned Wakeman, who was an ex-investment banker. And Genghis Lloyd Harris is our chairman. He was an ex-Abingworth partner. And then we've got Nigel Brooks, who's our CDO, and he's led projects like this from within large and small biotech. Mark Cullingworth is our CFO. And then we've got two clinical advisors. Beverly Hunt is one of the key clinicians that has driven the use of the standard of care to be actually widely adopted. And that she's done it internationally and nationally. And yet she still sees the unmet need of the current standard of care. And that's why she's really supportive of this program and to improve the efficacy of that standard of care. And then we've got Nikki Curry, who's leading in trauma, and she's previously led clinical studies. Next slide, please. So there's still high bleeding as a consequence of trauma and surgery, leading to mortality. In the US, trauma is the primary cause of death in individuals under the age of 46, and 40% of that is because they're bleeding. And in surgery, there's still a lot of bleeding that increases the rate of mortality. Next slide, please. So tranexamic acid, the standard of care, whilst it's better than no drug at all, it's still not as efficacious as it could potentially be, but yet it does reduce death due to bleeding by a third in trauma and postpartum bleeding, and it reduces bleeding a third in surgery. But its effect is limited because it can't block the actual enzyme that's responsible for clot breakdown, plasmin. So what we're doing, we're calling our approach CP101. We're directly selectively inhibiting that enzyme that actually breaks down blood clots. And that will give us greater efficacy and therefore reduce mortality. And as I previously mentioned, because plasmin is responsible for inflammatory effects, it will also actually reduce the number of patients being admitted to intensive care with multi-organ failure and obviously improve their mortality outcomes. Next slide, please. So this is what happens when you have an injury. You normally get a fibrin scaffold that's formed from a series of reactions that converts fibrinogen, which is a soluble plasma protein, into fibrin, which is an insoluble fibrin mesh that holds the blood clot together. Plasmin is the enzyme that can break down fibrin at the right time, and this process is called fibrinolysis. In addition, plasmin can initiate inflammatory responses. And there are 3 ways that you can generate plasmin from its precursor plasminogen. Next slide, please. If you could, next one. So standard of care tranexamic acid, the way it works is, next slide, it actually blocks this TPA cleavage of plasminogen to plasmin. So it reduces the amount of plasmin generated. Next slide, please. But what it also can do is actually bind to plasminogen and increase the amount of UPA cleavage of plasminogen to plasmin. Next slide. It doesn't do anything to this kallikrein pathway, but the net effect, next slide, please, is that it actually reduces the amount of fibrinolysis. But key important point, it doesn't block plasmin itself. So if you have any plasmin that's there at the time of injury, so you've just been run over, say, you've got plasmin generated, it won't block any plasmin that was there circulating when you get treatment. Next slide, please. So what we're doing with our approach is we're directing the active site, blocking the enzyme response for clot breakdown directly. And as a consequence, we're blocking all 3 pathways. But importantly, we're blocking the plasmin that was there before treatment as well. So we'll have more effect. Next slide, please. So the reason we're confident that we can do that is this just is an in vitro model of clot formation and clot breakdown. If you look at the line in black, this is what happens in the absence of drug. Next slide, please. You basically form your clot and then it gets broken down by the conversion of TPA in this case, or UPA kallikrein, cleaving the plasminogen that's in the system. Now, as you add the therapeutic amount of tranexamic acid, you can see that you're prolonging the time it takes to achieve clot breakdown, and the area under the curve is indicative of the stability of that clot. When you add one of our agents, you can see that you're really protecting the clot, and that's even at a lower dose. That concentration is equivalent to the lighter red one here. So you can see that you're really actually blocking that clot breakdown. And this is true for all the pathways of generating plasmin. Next slide, please. So what this is going to achieve is better efficacy, reduced mortality, less inflammation. You're going to save more patients from multi-organ failure. You're going to have shorter hospital stays, less blood products, and ultimately lower costs. So this is our development pathway. Essentially, we're at lead series selection, and we're going to progress this first phase of funding all the way to achieving being ready for first-in-man study. Next slide, please. So we've had pre-seed funding. O2H were our first investors, and this money will take us towards the middle of next year. And what we then aim to do is select our candidates and then perform the preclinical package to take us ready for that first phase 1 study in man. Next slide, please. So with respect to the fact that we are replacing a generic drug, there are precedents for this with the oral anticoagulants that replaced warfarin. They came in at 20-fold above the generic price. And there's 2 scenarios here, one that was around 7.5 as well. So the market for tranexamic acid is in the multi-$100 million. But we believe that the way that the benefits of our drug will be able to achieve $1 billion multiple revenue. Next slide, please. So this just shows you the potential market that we're dealing with, and it's segmented by the different indications. But ultimately, there is the potential of a 7.2 billion sort of market in this space. Next slide, please. And if you look at a licensing deal, this is a typical upfront payment for a successful phase 2 asset is 310 million, with a royalty rate of around 11 to 12%, and a royalty per annum where sales are greater of $1 billion in the region of 110 to 120 million. Next slide, please. So just to summarize, what we're doing is developing a first-in-class selective plasmin inhibitor to address the unmet needs of tranexamic acid. We're looking to raise 10 million with a syndicate of investors, and we've already got some interested investors. And we are going to achieve greater efficacy than the standard of care and reduce deaths not only from bleeding, but also from multi-organ failure. Thank you.
Brilliant.
Two questions, one clinical and commercial. How are you going to test this? In what is your phase 1B or your phase 2 cost look like? And are you going to, it's a new reagent, the mechanism is somewhat novel. The authorities want to see, you're going to do a taper study, are you going to do a topic standard of care? How are you going to do the experiment and show it works? The second one is part of that is what's your addressable market? We talked about general market sizes when investors hate that stuff, like $7 million. Why is that segment of your addressable market? Why are you going to win there? What does that do to TPP? Rather than say it's a $7 million market, I'd rather say it's a $350 market, but you know why. So one is what does your clinical trial look like? And the second is how do you do it?
So it's a phase 1 study. There are biomarkers that we can use to actually measure efficacy as we're actually doing the phase 1, doing the dose finding studies. The phase 2A study, we're looking at knee surgery where there is bleeding happening. So we will monitor blood loss, blood products required, and actually sort of, hospital stays within that knee surgery study. Now, there's a precedent. I mean, there's been over like 200 clinical studies for tranexamic acid. So it's not like we're doing something completely new. There's precedent for how studies have been performed previously. And just to add to your comment about, so proteinin was like a bovine-derived biologic that was on the market, and predominantly that inhibited plasmin, which is what we're trying to do. But it was not selective and it had off-target effects and it was withdrawn from the market. It subsequently got reinstalled into the market, but nobody is really using it anymore. So I think based on that, we believe that we will probably be able to use it as on its own.
What peak sales for that?
So that was priced at $1,000 per dose at the time, and I think it was like a couple of $200 million or so. So yeah, and I guess that we're still doing more work on the actual addressable market, but what I've done is only shown you some of the actual segments of the indications that we could go into. But what we believe is that we're actually going to change clinicians' view with respect to the fact that more people would want to treat it. So we're still actually doing clinician work to actually look at that in more detail. I don't really want to sort of make something up here and now, just to, yeah.
And last final question to Peter.
Yeah, being provocative, I think your total addressable market is about 5 individuals, because they are you're not going to take this to market. Highly unlikely from sitting here, you're going to be taking this drug all the way to, you're going to do your licensing at the end of phase 2.
Yes.
So the real question is how much to get you there, plus a margin of safety while you do your licensing deal, and who are the 5 people being the gatekeepers in the companies that have this as a therapeutic focus and where this is a key that unlocks the door for them strategically. And also, what are those companies themselves doing in their pipelines? Because if it's key strategically for them, they sure as hell aren't sitting there doing nothing. So I think so. My question is: who are those 5 companies? Who are those 5 people? And why are they going to buy your product in 9 years' time, 8 years' time?
Good question.
Yeah,
That's the last question, but it's a great question.
that is a great question. So we've actually started talking to those people from now. We've actually identified one company that specialises in this area. I don't want to name them. They specialise in the area, and actually they're interested in actually potentially licensing from now. We want to actually develop it further before we potentially. We're in discussions. Let's put it that way. And then there's 2 other companies that have also expressed interest as well. Which, yeah. So I guess there is interest, and we're exploring that relationship from now. Yeah.
Thank you.
Thank you. Thank you very much.